Good afternoon, and welcome to this session. We talk about Longhorn. And I'm Derek Su from SUSE, and also one of the co-maintainers of Longhorn project. Okay, in this session, I will give an introduction to Longhorn and attract more and more adoptions and users, and also external developers to contribute to Longhorn and bring Longhorn to the next level. Okay, this is my agenda, and we will talk about the overview. Maybe some of you here may be familiar with Longhorn, or some of you might want to try Longhorn in your environment. So I will talk about what is Longhorn and why we need Longhorn. And then I will give an update of our project and our release policy. And more, we will talk about the Longhorn details, including the architecture, capacities, V2 data engine. Currently, the V2 data engine is our experimental feature, but the performance is very good, and we want to move it to a stable state. Okay. And what's new in the 1.9? 1.9 is just released in this May, so we will talk about the new features, and our new features planned in 1.10, and the community status update. Okay, take a look at the Longhorn overview. Okay, Longhorn is a cloud-native distributed bus storage for Kubernetes. So you can create a Kubernetes cluster, even a single node cluster. Then you can install Longhorn in one single command. So everything will be there. So you can use your workload with a persistent variant. And also Longhorn support HA persistent variant. It means every Longhorn variant can have multiple replicas. So if one of your replicas is somehow gone or somehow corrupted, Longhorn will help to rebuild a failed replica from a healthy one. So you don't need to worry about your data or losing your data. Okay, and also Longhorn support built-in incremental backup and restore, and also the snapshots. So you don't need to install any third-party backup solution. You can use the built-in backup solution to protect your data. Okay, based on the backup and restore functionalities, Longhorn support cross-cluster disaster recovery. It means if you have a two cluster, you can create an active standby variance to protect your workloads and your data. If your cluster is somehow running into a disaster, you can activate your workloads in another node in very short time to shorten the downtime. Okay. And also, Longhorn is a platform-agnostic solution. So you can install Longhorn on different Kubernetes distros or Linux distros. Okay. And now, Longhorn is an open source project and owned by CNCF. So it is an incubating project. We want to move it forward. And so we hope more and more developers can join Longhorn and to bring it to graduation status. Okay, this is the official website of the Longhorn. Yeah, so you can click here to check the details. Okay, and our project status and release policy. Okay, according to the GitHub start history and our metrics in Longhorn, you can see Longhorn receive more and more attentions and adoptions over the past years. Okay, currently there are 160K nodes and over 60 clusters are running Longhorn. So Longhorn is very popular, in the community. Okay. And if I remember correctly, there are some nodes running several hundred nodes. Yeah. So there are some clusters have a lot of nodes, several hundreds. So the clusters running for several years. So Longhorn is very stable for now and for production environment. Okay, and we can talk about where can Longhorn be used. The first one, Longhorn is very flexible. So we see user install Longhorn in the home lab cluster, edge cluster, on-prem cluster, or private cloud or public cloud. And in addition, for the use cases, we see people use Longhorn in AI domain, telecom domain, data management, data analysis, virtualization, observability, and so on. For the virtualization, because Longhorn support live variant migration, we see some people use Longhorn with qvert. When you use qvert, you want to move your VM from node A to node B. So you have to move your variant to different node. So Longhorn is a very good and strong choice for qvert. Okay. And we see the end user and service provider and solution providers are using Longhorn. Okay. So, and next, for the OS compatibility, Longhorn is an agnostic solution. So you can install Longhorn in traditional OS such as Ubuntu, SUSE, Slash, Red Hat, and so on. You can also install Longhorn on immutable OS such as Talos and Slash Micro, something like that. Okay. And this is our release cadence. Currently, we ship Longhorn feature release every 4 months. So you can expect each January, May, and September, we will release a feature release. And we will roll out a patch release every 2 months. So from the schedule, we just released 1.9.0 in this May. So we will release a patch release in July, 1.9.1. And we will release a new feature release in September, 1.10. Okay. And in addition to the feature release and patch release, we also release Spring images every 2 weeks to help us hunt the potential issues or regressions in Longhorn. Okay. And for the test cases, originally we have end-to-end test cases based on PyTest. But now we introduce the Rubble framework to improve our test cases. Okay, based on the Rubble framework, we can make our test cases more readable and easy to maintain. Okay. In addition, we also introduce negative test cases to help find out the issues when the cluster is restarted or the node is down or rebooted or network partition. So over time, we will improve the test coverage to help Longhorn get more stable. Okay, and let's take a look at the Longhorn details. Okay, before looking into the details, we can take a look at the design principle. Longhorn focuses on 3 points: reliability, usability, and maintainability. Okay. For the reliability, Longhorn is a crash consistency design. So if there is something wrong and your variant is somehow corrupted, you can expect Longhorn can help you recover or salvage the data without using your data. Okay. And for the data protection, Longhorn takes data protection very seriously. So we have many built-in techniques to protect your data. For example, the snapshot and the backup, restore, and the DR variant. So you can protect your data on demand, or you can configure recurrent job to take the backup periodically, okay, to reduce the RPO. Okay. For the usability, we have a one-click installation method. So the installation is very simple. Okay, we also have one Longhorn CLI. The CLI can help you install or check your environments. So you don't need to prepare a lot of steps to install the requirements. We already have one tool to help you install everything Longhorn needs. And according to our experience and the feedback from the community user, we constantly polish the user experience. So we make the Longhorn usage simple and make it easy to maintain. Okay, we also provide the comprehensive documentation. So if you have any questions, you can go to our website and you can check the document. There are a lot of use cases and steps or workarounds to help you use Longhorn. Okay. And for the maintainability, the architecture of Longhorn is simple, so it's very easy to understand. Okay, because it's simple, so if you have any worst case scenario, we can help you rescue your data and recover your variant. Okay, then we can take a look of the Longhorn architecture. Okay. Longhorn is based on the Kubernetes design. So there are two interfaces to interact with Longhorn. The first one is the CSI. Okay. CSI, and the other one is Longhorn UI. So both of the interfaces are interacting with Longhorn use the Longhorn API. So the Longhorn API. So if you create a Longhorn variant, or you create a workload with a variant, the Longhorn CSI plugin will help to create a Longhorn variant resource, Longhorn variant CR. And our Longhorn manager, this is the core of our control plane, will watch the creation of the Longhorn variant resource and create the corresponding engine CR. Okay. The engine CR is in our database. Each engine CR is corresponding to engine instance, runtime instance, and each engine CR can have multiple replica CRs. For example, if you have 3 replicas of this variant, you will have 3 replica CRs. Okay, and each replica is corresponding to 1 replica instance, runtime instance. Okay, so from the picture, you can see there are 3 layers. The first one is interface layer, and the second one is the control plane. So the Longhorn manager will watch the variant CR creation, deletion, or update, or snapshot create, or backup create. Yeah, and we have a data plane. Yeah, so the data plane is the engine and replica. And then we can take a look at the data plane. When you create a Longhorn variant, Longhorn will help you create a bulk device. And the bulk device is based on SUSE protocol. This is for V1 variant. Okay. So this is your workload, and the underlying parts are Longhorn bulk device. So when your workload application issue an I/O to the file system will forward the I/O to the SUSE block layer. And in the SUSE block layer, it will send the I/O to the SUSE initiator. And the initiator will forward the I/O to the SUSE target. So in the SUSE target, we have a Longhorn TGTD. So this Longhorn TGTD will send the I/O to the engine instance. Here, the engine instance is an engine process. So it will receive the I/O and send the I/O to the downstream replicas. So if your I/O request is a write request, Longhorn will send the I/O to all the replicas to achieve strong consistency, to make all the data in the replicas are identical. So that's why when you lose one of the replica, we can rebuild the one from a healthy one. Okay. So if your request is a read request, Longhorn will send the request to one of the replicas to speed up the I/O processing. Okay, so this is the I/O flow of the Longhorn. Okay, we can take a look at the Longhorn capacities. And currently, Longhorn support block and file system variant modes. And we also support read-write once and read-write many SS modes. For other SS modes, we will implement them in the future. Okay, or if you have time, you can contribute to Longhorn as well. Okay. And for the CSI protocol support, we support most of the operations, including variant provisioning, attachment, snapshot, cloning, and variant expansion, and variant restore. Okay. And variant capability, Longhorn is based on theme provisioning to achieve space efficiency. Okay. And we also support copy and write based snapshots, and train operation, expansion, and live upgrade and live migration. Okay, I will introduce the live upgrade and live migration later. And for the I/O performance, if you have a workload, you can schedule the replica too close to the workload to reduce the overhead of the networking. Yeah, so you can reduce the latency and improve the I/O performance. Okay, we also have a local variant to speed up the performance. And later you will see the benchmark result. V1 Valorant cannot offer good performance, so we introduced V2 data engine. Yeah, and the V2 data engine's performance is very promising. And so you will see the numbers later. And we also provide an intuitive UI, so you can operate Longhorn on the UI. And we also support the CLI. The CLI can help you install the requirements and check your environments. And we also have some rescue functionality and other Valorant operations in the CLI. Over time, we will improve the tool and to make the tool like a Swiss knife, yeah, for everything in Longhorn. Okay. And we also have a monitoring matrix, okay, to watch the status of Longhorn. Yeah, again, we will improve it over time. So if you have any matrix want Longhorn to support, you can contribute to Longhorn as well. Okay. And we also support the storage topology based on the storage tag and so on. And for the data protection, we support the replication. So as I said, Longhorn Valorant can have multiple replicas. So we can support your data using the HA method. And we also support data encryption based on Linux kernel dmcrypt. And okay, if your Valorant is somehow broken, I mean the replica is somehow broken because of the silent corruption in the file system, Longhorn can aware of the corruption and rebuild the failed replica. Okay. And also for the data part, we support a snapshot, backup restore, and a DR Valorant. And we also improve our data reduction as well. Okay, we can take a look at the Valorant snapshot. Okay. Okay, when you create a Longhorn Valorant, Longhorn will create a sparse file. Okay, and we call this Valorant head. Then you can write data to the sparse file, and you can take a snapshot. When you take a snapshot, the original Valorant head will become immutable, and Longhorn will create a new Valorant head. Yeah, this is also a sparse file, and you can write data and take a snapshot. So this become immutable, and this new Valorant head, and create a new one, and take a snapshot and write data. Okay, so when you are going to read the data from the second block, Longhorn will read the data from snapshot 1. When you are going to read the data from the third block, Longhorn will read the data from the Valorant head. So overall, you will see the data like this. Okay. And for V1 Valorant, the snapshot file or the Valorant head is a sparse file. For V2 data engine, because we rely on the SBDK, so for V2 data engine, the snapshot or the Valorant head is a logical value inside the SBDK. Yeah. But both of them support the thin provisioning. Okay, so based on the copy and write snapshot, we support incremental backup. So when we are doing backup, we can find out the new block and only back up the new data. Okay. In addition, we also support full backup. Before, we only support full backup and then always incremental backup. Now we support full backup, incremental backup, and you can do full backup again to improve the data resilience of the backup storage. Okay. And we also support compression. And currently, the backup block size is 2 megabytes. I think it's too small. So a lot of users want to increase the value. So to reduce the get and put operation while backup and restore to save the cost. So in the future, maybe in 1.10, we will make it configurable to reduce the cost. Okay, for live upgrade migration, okay, this is the stack of the data plane. So we have a front-end iSCSI, and then we have an engine process, replica process. So each replica process has a sparse file or snapshots. Okay, when you are going to live upgrade or live migration, Longhorn will create a new set of engine process and replica process. So the idea is very simple. So we create a new engine and we create a new process. And the new process point to the original disk file. Okay, then we can redirect the I/O to the new engine. then we delete the old one. So finish the variant level upgrade or level migration. Okay. So based on this method, you can use KubeVirt with Longhorn variant to migrate your VM as well as the variant. Okay. And Longhorn also supports a disaster recovery variant. The idea is very simple as well. We have assume you have a two cluster, cluster A and cluster B, and you have an active workload and variant, Longhorn variant. Then you can create a standby workload in the cluster B, and you can create a standby variant here. Okay. Then you can let Longhorn do periodically incremental backup. So you can take snapshot and backup the data to the remote storage. And in the cluster B, the Longhorn here can be aware of the data, the new data in the backup store, and pull the data and do periodically incremental restore. So you back up and restore, back up and restore. So when your cluster A is running into a disaster, so you can activate the Longhorn variant and the workload in cluster B, and to reduce your service downtime. Okay. So this is not a fault tolerance, but it's a HA method. Yeah. So you can reduce your data, lost data. Okay. And we can talk about the V2 data engine. This is a very important feature for Longhorn. And it's a next generation data engine in Longhorn. And the V2 data engine is based on SBDK, and it can achieve very high I/O performance. Okay. And why we use SBDK? Because of the performance and how to achieve the high I/O performance. The first one, SBDK use polling mode instead of interrupt mode. So if there is a file, SBDK continuously polling the FD to read the data. So the I/O efficiency is very high. But we need a dedicated CPU cores. It means you have a 100% CPU cores usage when you're using V2 data engine. Okay. And in addition, SBK needs huge pages. So we don't rely on the Linux kernel's memory allocation and deallocation. The memory is managed by SBDK internally. Okay. Okay, and the storage stack of V2 data engine is very similar to V1. So for V1, we have a iSCSI protocol. For V2, we use NVMe OF protocol. Okay, and in 1.9, we introduced ublk. ublk is a local block layer protocol. So there is no network overhead. So we expect ublk can provide better performance than NVMe OF. Okay. And for the controller, V1 variant is engine process. Okay. Instead, for V2 variant, it is RAID 1 BDEF in SBDK. And for V1 variant, each process has multiple downstream replicas. So if engine receives I/O, the I/O will pass to the downstream replicas. Okay, so the downstream replicas are actually replica process and sparse file. Okay. For V2 data engine, the RAID 1 BDEF has multiple base BDEF. So each base BDEF is a logical variant. Okay. So when you issue an I/O, the I/O will send to the downstream as logical variant inside the SBDK. Okay, and we can take a look of the I/O path. So again, if your application workload issue an I/O to the file system, the file system will forward the I/O to the NVMe OF layer or ublk layer. And the initiator will send the I/O to the SBDK target. Okay, and then SBDK target will send the I/O to RAID BDEF. RAID 1 BDEF, and RAID 1 BDEF will send the I/O to the downstream logical variant and persist the data. Okay. So the IO path is very similar, but the implementations are very different. Yeah. Okay, we can talk about what's new in 1.9. Okay, in 1.9, 1.9 is just released in this May, last month. Okay, we introduced several key features. The first one, offline replica rebuilding. Before adding this feature, Longhorn is unable to rebuild failed replicas of a detached variant. So if your variant is detached, Longhorn cannot protect the data. Okay, after adding this feature, Longhorn can be aware of the degradation of a detached variant. If a detached variant is somehow degraded, so Longhorn will attach this variant and rebuild the failed replicas and unmount detach the variant. Okay, so now Longhorn can provide full HA for both the attached and detached variants. Okay, so you don't need to worry about the the variant health of Longhorn anymore. Okay. Okay, we also introduced the orphan instance cleanup mechanism. So Longhorn can periodically scan the runtime instance, for example, the replica process and the engine process, and compare the instance with engine CRs and replica CRs, and figure out if there is any orphan resource inside the cluster. If there is any orphan process, orphan engine process, orphan replica process, Longhorn can be aware of this and clean them up to save your computing resource or memory resource. Okay, we also improve the metrics and observability in 1.9. And for V2 data engine, we introduced ublk front end to improve the I/O performance. Okay, we also introduced offline replica rebuilding and storage network for V2 data engine. Okay, we can take a look at the I/O performance benchmark. And we did a benchmark on Equinix. And we have 3 nodes. And the storage is NVMe SSD. So on each node, we have 1 NVMe SSD. Okay, and the OS distro is Ubuntu 24.04 and kernel. And we benchmark IOPS throughput and latency. So this is the parameters. Okay, for the IOPS, the gray bar, before the numbers, this is single replica variant. This is single cross-node replica variant. It means your engine is on node A, but your replica is on node B. Okay, and this is 3 replica variant. Okay, so you have 3 replicas. Okay, and for the gray bar, it's the baseline. Okay, it's from the local path provisioner. Okay, and the red bar, you can see this red bar. The red bar, yeah, it's the performance IOPS of the V1 variant. Okay, so you can see the read IOPS and write IOPS of V1 variant are not good enough. Okay, so that's why we introduced V2 data engine. Okay, for the green bars, you can see the green bars. They are V2 data engine using NVMe OF front end. So this is the single CPU core. We assign single CPU core to Longhorn SBDK, TGT, D. And this is 2 cores, and 4 cores, and 6 cores. So when you add more CPU cores to SBDK, to V2 data engine, the IOPS, the read IOPS and write IOPS can be better. Okay, so if you have more CPU, you can get good performance. Okay, but it means you need more CPUs. Yeah. So this is a question. We will check this later. Okay, for the throughput, you can get very similar result. Yeah. Okay. And for the latency, from the picture you can see SBDK V2 data engine with NVMe OF can provide lower latencies for both read and write. Yeah, so before, V1 Valor is not very suitable for database because of the high latency. Now, for V2 data engine, V2 Valor is very suitable for low latency application compared to V1 Valor. Okay. In the future, we will provide the numbers of ublk front end. We expect the ublk can provide lower latency than NVMe OF. Okay, we can talk about the features planned in 1.10. 1.10 will be released in this September, so we hope we can add more features in it. Okay, and for V2 data engine, V2 data engine is very important for us, so we talk about this first. We will continuously improving the stability and resilience, okay, because Longhorn encounter many, V2 data engine encounters many bugs in SBDK or in Linux kernel. So we are constantly improving these two parts. And for the performance, we will improve the ublk continuously, constantly. Okay. And we want to introduce interrupt mode in SBDK. Because SBDK currently relies on the poly mode, but poly mode needs dedicated CPU cores. So we want to use interrupt mode. So we don't need to assign CPU cores to SBDK. I think the performance will be worse than use dedicated mode. But in some cases, for example, in some edge cases, edge scenarios, we need interrupt mode to reduce the CPU consumption. Okay. And for the replica rebuilding, we will add a snapshot-based delta rebuilding to speed up the rebuilding process. In addition, we will introduce the QoS for replica rebuilding. For V1 or V2 Valor, when there is replica rebuilding, the rebuilding I/O will impact the stability of other Valors. Yeah. So we can use the QoS to throttle the rebuilding I/O to make the whole system more stable. Okay. And for the Valor capacities and operations, we will support the phase Valor cloning. And we will add Valor expansion, and we will support engine life upgrade. Okay. And for 1.10, we also want to support IPv6 for V1 data engine. Okay. Maybe we can support V2 data engine as well, but V1 is first, because currently a lot of users still are using V1 data engine, and V2 is an experimental feature for now. Okay. And we will make the backup block size configurable. So user can expect when they are doing backup or restore to save the cost, okay, to reduce the get and put operations and save the cost. Okay. And our community status. Okay, Longhorn just add a new page, community, in our official website. So in this page, you can go to Longhorn website and you can find the community page. And in this page, you can find out our social media channels and our mailing list. So if you have any questions, you can reach out to us. Okay. And we will have monthly meetups. So this week, we will have a meetup in North America. This is an online event, so you can join virtually. And we will have, next month we will have an APEC meetup in July 17th. So hope we can see you online, okay? And if you need any help, you can go to our GitHub issues or discussions. And no need to worry too much. You can create a ticket, and we have a community coordinator to help you to organize the questions and help answers or figure out a solution. Okay, and you can also reach out to us on CNCF Slack Longhorn channels. Okay, so again, we have a community coordinators to answer the questions as well. Okay. Okay. And if you go to Longhorn repo, you can find a new file, adapters. So if you are using Longhorn in your production environment, or either in experimental environment, you can share your use case with us, and add your use case in this file, adapters, okay, to promote your companies, okay. Okay, and we are currently want to move Longhorn forward. So if you are interested in Longhorn, you can get involved in Longhorn more. So you can contribute to Longhorn, for example, the control plane, data plane, CLI, ecosystem tools, monitoring, documentation. So we welcome any contribution from our community. Okay. And thank you. Any questions? Okay, if no questions, I'm here. So you can reach out to us here, or we have a table. Yeah, so you can go to my table and we can discuss more. Okay, thank you.